So we'll take a quick look at some of the other object-oriented features of Scala. Though Scala does have full support for functional programming, functions are not top-level constructs in Scala. When we're in the interpreter, we're able to go ahead and enter expressions directly and enter unenclosed functions and have them evaluated. However, when we're writing program code for compilation, functions need to sit inside of a top-level construct. There are only 4 top-level constructs. Functions are not one of them. They're objects, classes, case classes, and traits. So objects we've already covered previously, and classes we have as well. Just a few things to remember, to reiterate, is the different way that constructors are implemented in Scala. The constructor parameters are integrated into the class definition signatures, and anything that is not enclosed in a method inside of your class body is actually part of the constructor. Another thing to reiterate is the common practice of companion objects, which hold static code associated with instance-specific class code. Classes can be extended in the same way they can be with Java or any other object-oriented language. Abstract classes are supported, and traits and mix-ins can be combined to form new classes. We'll talk about those in a second. Case classes, just very briefly, they're immutable data objects that depend completely on their constructor arguments. They're sort of they're a functional concept, and they allow some things like pattern matching, which are generally reserved only for functional programming, to be brought to objects, as well as implicit equality comparisons. However, it's sort of beyond the scope of what we're discussing here. Case classes are controversial. They've been said to have been a quote failed experiment by some people. There's a link here if you're interested in reading up any more on it. There's all sorts of information you can find online if you're interested in looking up case classes. Traits and mix-ins we'll take a look at. They're similar to interfaces in Java. They are packaged up collections of attributes and behaviors that can be extended by or mixed into your classes. So new classes can be created by extending other classes, which is what you do in Java. You can extend traits as well in the same type of way. Or you can add in additional characteristics by using more than one trait, more than one collection of attributes and behaviors, different traits. And when you use more than one, we call this mixing composition, because you actually go about it in a couple of different ways, and I'll explain what I'm talking about here. So here we'll define a few traits. It says here, the trait keyword. This is all pretty straightforward. Smartphone, here we have some attributes specific to smartphone. Then we'll have a more specific trait for Android smartphones, which will have attributes specific only to an Android. Clearly, Android version wouldn't be something you'd see on an iPhone or any other kind of phone. So if we plan on using a single trait, then we use the extends keyword, and we treat that trait just like a class that we're extending. So class Samsung extends smartphone. Okay. If we want to use several traits, then we can only extend one class directly with the extends keyword. After that, we use with, and we can list any number of additional traits that we'd like to use when we create our new object, our new class. Sorry, when we do this, we call it mix-in composition. If we're using the extends keyword along with, that's a mix-in composition. If we're extending another class as opposed to a trait, then the class name would go here, and then with followed by a list of all the traits that we'd be mixing into that class. So the with keyword it's not meant for subclassing. We can't extend classes with that, whereas the extends keyword is applicable to both existing classes for extending as well as traits. With is reserved only for traits.